Happy learning! Today we're going to talk about the first fit coloring algorithm. Okay, so as we've seen in the last two videos, finding the minimum coloring of a graph to determine a chromatic number in general is a pretty hard process. And in practice, usually you don't need to get the minimum. If you just make sure you use not a ton of colors, that's better than using a lot of colors. Okay, it doesn't have to be the best. And so we're going to talk about the first fit coloring algorithm. This is going to be a way to, it's not going to guarantee we get the best possible coloring, using as few colors as possible, but it's going to be good enough for most practical applications. All right, so the input for this algorithm is a graph with vertices ordered as x1 through xn. All right, so if our vertices don't have an order to them, just assign some order. All right, so maybe this is our first vertex, and that's the second, and that's the third, that's the fourth, and so forth. Okay, so just have an order to our vertices. And if the vertices were already labeled like alphabetically, then alphabetical order is fine. All right, so what are the steps? The first step is we are going to assign our first vertex color 1. All right, simple enough. Step 2 is we're going to assign x2, so the next vertex, color 1 if possible. And if x1 and x2 are neighbors, then we'll assign x2 color 2. All right, so assign x2 color 1 if x1 and x2 are not neighbors. And then otherwise, assign x2 color 2. All right, so if x1 and x2 are not neighbors, we'll just give x2 the value of 1. Otherwise, we'll make it the value of 2. All right, and then the last step of this algorithm is we're going to give xi, so just x3, x4, x5, and so forth, the first color not used by any neighbor of xi that has already been colored. All right, so if xi has neighbors that are colored 1, 2, 3, well, then we're going to color xi 4. All right, and so the output of this algorithm is a coloring of our graph. Okay, it's not guaranteed to be a minimal coloring. There might be ways to color it more efficiently with fewer colors, but this is a very easy algorithm to run. Okay, finding a minimum coloring is hard. Okay, so let's work through this algorithm. I'm going to let this be x1, and then we're going to go the way of the clock, clockwise. So this will be x2, x3, x4, and so forth. All right, first step, assign x1 the color 1. All right, next, are x2 and x1 neighbors? No. So we could assign x2 the color 1 as well. x3 is neighbors with things that are labeled 1, so we have to label it 2. x4 has neighbors of 1 and 2, so we have to label it 3. Right? You see how this works? It's very simple. Our next vertex has no colored neighbors at this point. None of the neighbors have been assigned their color, so we can give it the value of 1. This vertex is neighbors with a 1, so it's 2. This vertex is neighbors with a 1, so we'll give it 2. This vertex is neighbors with a 1, 1, and 2, so we'll give it the value of 3. This vertex is neighbors with a 1, 2, and 3, so we have to introduce a new color of 4. And then finally, this vertex is neighbors with a 1, a 2, a 3, and a 4, so we do have to introduce another color, which is 5. All right, and so this is how you use the first fit coloring algorithm to color the graph. And it turns out, in this particular example, we actually did color it with the fewest colors possible. And how do I know that? Well, this vertex, this vertex, this vertex, this vertex, and this vertex form a clique of size 5. Right? And so we know the chromatic number is at least as big as the clique size. The clique size is 5. We colored it in 5, so we know our chromatic number actually is 5 in this case. All right? Well, that's all I have for today. I know it was a short one, but we're getting towards the end of this of the course. So we got one video left, and then that's it. All right. Well, take care. Let me know in the comments if you have any thoughts or concerns. All right. Bye-bye.